The last ice age. Millions of large animals roam the Earth. It's an age of giants.
Earth suddenly shifted from warming to deep freezing almost overnight in geological time. Buried in a thin, dark layer of ancient soil, scientists found clues that may connect an abrupt climate reversal, the disappearance of giant animals, and the decline of an early human culture. This mysterious band stretches across continents and raises one chilling question. Did a cosmic event trigger extinction and collapse, or was the cause something closer to Earth? The evidence remains unexpected, controversial, and impossible to ignore. The mysterious black mat. Across continents, buried beneath the surface at nearly identical depths, lies a strange and striking layer of dark sediment that has puzzled scientists for decades. This thin, almost charcoal-colored band is known as the black mat, and it holds a record of sudden and profound change. Archaeologists and geologists first noticed it while excavating Ice Age sites scattered across North America, particularly in the Southwest. What immediately made the black mat so curious was what it seemed to divide: a world teeming with massive creatures below and a drastically altered landscape above. Beneath this dark band, fossilized bones of mammoths, giant ground sloths, and other Ice Age giants are common finds, along with beautifully crafted stone tools of the Clovis culture. But above the black mat, those same fossils and artifacts suddenly vanish, as if a line had been drawn through time. The giants were gone. The Clovis tools disappeared. Across multiple continents, the black mat acts like a boundary between two radically different worlds. Its appearance is startlingly consistent, showing up not just in one isolated spot, but on different continents, inviting questions about what natural process could cause such a uniform and sudden change. The black mat's richness in organic material gives it its characteristic deep black hue. But that darkness signals more than just decayed plants and animals. It marks a shift in the environment and the return of wetlands, suggesting a pause or transformation in ecosystems as climates changed rapidly. More intriguing is that this band always appears at around the same time in the geological record, roughly 12,800 years ago. It is a global marker, but what exactly it signifies has long been debated, as it sits at the intersection of dramatic changes in climate, fauna, and human activity. Scientists have come to realize that the black mat is no ordinary sediment layer, but a frozen snapshot of a catastrophic moment. Curiously, this layer coincides with the disappearance of a particular culture, the Clovis people, and widespread extinction events. And yet, simply identifying the black mat does not solve the mystery. It only deepens it. What was the event or series of events that caused such a sweeping transformation, and how could it affect animals, humans, and planet-wide climates all at once? Leading geoscientist C. Vance Haynes spent years meticulously documenting the black mat across dozens of sites. His work showed that this was not a random anomaly, but a persistent, distinct feature in the sediments. While some considered it just a mark of local environmental shifts, others sensed there was a bigger story encoded here. Despite intense study, the black mat defied simple explanation because everything above it looked so changed compared to what lay beneath. Over nearly 2 decades, this layer remained a subject of debate and investigation, with no consensus emerging. Some researchers viewed the black mat as evidence of gradual change. Others argued it was the scar of a sudden event. It was clear that deciphering what lay in and under this mysterious dark band could provide answers to puzzles about the abrupt climate shift and the simultaneous losses in biodiversity and culture. Still, no straightforward cause was agreed upon, leaving an unsettling question lingering since its discovery. The uncertainty only grew as signs pointed toward a complex trigger, something beyond normal environmental cycles. While the black mat was easy to locate, interpreting its meaning required new methodologies and cross-disciplinary studies. Starting in the early 2000s, teams of scientists began analyzing the black mat grain by grain. They focused on what was trapped inside: microscopic minerals, carbon residues, and rare materials that might reveal the hidden history sealed in the layer. What these laboratories uncovered turned the black mat from an obscure sediment layer into a battlefield of ideas, suggesting forces far more extraordinary than previously imagined. The evidence hinted at not just a planet-wide climate event, but potentially an impact from space. Until now, however, these clues were scattered and contested, floating in the realm of possibilities rather than certainties. What lay beneath that black mat might hold the secret to an event so profound it reshaped the world, but first, we must understand the climate upheaval it marked. It was a global climate reversal unlike any other, and its timing perfectly matched the black mat's appearance. The Younger Dryas climate reversal. Around 12,800 years ago, the Earth's steady march toward warmth and renewal seemed to pause then, snap back into deep cold. After thousands of years of gradual warming that came after the last glacial maximum, this abrupt chilly interval took scientists by surprise, not only for how fast it hit, but for how strongly it showed up. It is called the Younger Dryas, and it lasted roughly 1,200 years, like the whole planet was rewinding itself, while glaciers pushed forward again and temperatures dropped abruptly across much of the northern hemisphere. The name Younger Dryas comes from a small Arctic wildflower, Dryas octopetala. Pollen from it left behind a clean signal in the sediment layers from this time, basically flagging a shift back toward colder tundra-like conditions. In general, climate changes unfold over centuries or millennia, but the Younger Dryas was nearly immediate in geological terms, which made it one of the sharpest cold reversals on record. This about-face interrupted the Earth's warming path and, for a while, slowed or blocked the advance of forests and grasslands. Because of that, many animals that relied on those habitats also suffered, kind of like the ecosystem got interrupted mid-gesture. Scientists stay really uneasy about how sudden and synchronized this cold spell was. Climate feedback loops can be slow and kind of spread out, but the Younger Dryas feels like a global reset button. It makes ecosystems and species go through abrupt, dramatic change. For people experiencing it, including early human groups, the impacts must have been awful and confusing. Temperatures fell, ice sheets moved forward, and life had to retool fast, or simply perish, almost with no warning. The reason for this switch has been a geological mystery for generations. A lot of researchers used to lean on the idea that disruptions in ocean circulation drove it, due to huge amounts of fresh water entering the North Atlantic. Meltwater from shrinking ice sheets supposedly diluted the salty ocean flow, and then the conveyor belt that carries warm water northward got shut, leading northern regions into cold. That explanation might cover some things, but it still leaves a pile of unanswered details about when it happened and what came along with it. To make matters stranger, the start of the Younger Dryas lines up exactly with the creation of the black mat layer. This match really hints at a shared spark behind the sudden chill, the vanishing of megafauna, and the downfall of a human culture. The way the shift arrives, so fast and compressed, plus other clues, suggests a specific event or chain reaction that was much more sudden than slow melting and ocean changes by themselves can comfortably explain. A bunch of scientists are intrigued by this timing because it kind of points to climatic vulnerability in those transition periods, you know? The Earth might have been on a knife edge, with ecosystems and human communities sort of finely tuned to warming states. The Younger Dryas could be read as a kind of cautionary example, what shows up when that balance is unexpectedly nudged off course. Still, what or who pulled the lever stays a topic of active exploring and arguing. This cold reversal wasn't the same everywhere. It hit the northern hemisphere the hardest, though the climate ripple effects moved around in more complicated patterns globally. The swift rebound of ice sheets slowed or even flipped ecological progress from millennia, sending ripple effects through animal populations and also human groups trying to keep thriving in a shifting world. Basically, it was a planet-scale episode with major consequences. The collapse of life forms and cultures around that time paints a more personal picture of this deep freeze than climate data alone can reveal. Disappearance of megafauna and humans. At the same moment that temperatures plunged during the Younger Dryas, massive Ice Age animals vanished from the landscape almost entirely. Mammoths, mastodons, giant ground sloths the size of cars, saber-toothed cats, dire wolves, and numerous other majestic species disappeared from the fossil record with startling rapidity. This extinction wave swept across North America and much of the world, marking the end of a chapter dominated by these megafauna. The scale and speed of these losses are remarkable. It happened so fast, geologically speaking, that many species vanished within what amounts to a blink of an eye in Earth's history. Scientists debate the causes, but the extinction coincides closely with the black mat layer and the onset of the younger Dryas cold period. These events suggest a strong connection between climate stress, habitat changes, and possibly a sudden environmental catastrophe. But it wasn't only the giants that disappeared. A sophisticated human culture known as the Clovis people also abruptly vanished around this same time. Named after artifacts first discovered near Clovis, New Mexico, this widespread culture was famous across North America for its distinctive stone spear points, often featuring a flute or groove down the middle. These tools were optimized for hunting large game, demonstrating a deep dependence on the Ice Age megafauna. For centuries, Clovis people were the dominant toolmakers from coast to coast, skillful hunters whose entire economy and lifestyle revolved around these massive mammals. Then, around the younger Dryas boundary, their toolkit and clear archaeological signatures suddenly stop appearing in the record. Whether the culture collapsed, scattered, or evolved beyond recognition, its disappearance was sharp and comprehensive. The loss of the megafauna and the Clovis culture were closely intertwined. Without the giant animals to hunt, the Clovis way of life lost its foundation. Their spear points were no longer effective. The abrupt environmental and ecological changes rendered generations of knowledge and skill obsolete in what must have been a deeply destabilizing moment. This triple coincidence, the cold reversal, megafauna extinction, and cultural collapse, is more than a curious overlap. It poses a complex puzzle about cause and effect. Scientists wonder if a single event triggered all three, or if multiple forces converged at the same time. The nature of the black mat, and what lies within it, remains at the heart of this mystery. Understanding why these massive losses happened simultaneously is critical not just for reconstructing the past, but for learning how rapid environmental changes affect life on Earth. The disappearance of these giants and the culture that depended on them marked a profound reshaping of ecosystems and human history. As we connect these pieces, a startling possibility arises. These losses were not separate disasters, but facets of a single catastrophic event. That idea challenges traditional explanations and demands a closer look at what might have triggered such a planetary upheaval. The clues hidden beneath the black mat suggest that the answer lies not just on Earth, but potentially in the sky above. The cosmic impact hypothesis emerges. In 2007, a bold new theory started to shift how scientists looked at the sudden climate reversal and the extinctions around the very beginning of the younger Dryas. A group of researchers suggested this cosmic event, like a comet or an asteroid, or more likely a scattered swarm of fragments, hit, or maybe exploded, somewhere over the northern hemisphere. In their view, this event released enormous energy, which then sparked broad wildfires, messed with huge ice sheets, and tossed all kinds of debris up into the air. That debris, in its own way, then cooled the planet quite a lot, pushing Earth back into a harsh, deep freeze, and basically creating a clear break from the slower warming trend that had been unfolding beforehand. This theory, known as the younger Dryas impact hypothesis, suggested the black mat was partly the residue of this catastrophe, like a physical scar left in the soil by skies raining cosmic fragments. The impact would have been powerful enough to wipe out ecosystems and reshape the environment almost instantly, or at least that is how it sounded in the early papers. It also offered an explanation for the sudden loss of the megafauna and the Clovis culture, tying together three long-standing puzzles with one dramatic cause, which is also why people got so heated. But such a sweeping claim naturally ignited fierce debate among Earth scientists, many of whom found it nearly impossible to accept without compelling proof. Another compelling clue was nanodiamonds, diamonds measured at the nanoscale, sort of embedded within the boundary sediments. Some of these nanodiamonds showed a rare hexagonal crystal structure usually linked to the kind of shock pressures you get from cosmic impacts. Diamonds need immense heat and pressure to form, and finding this kind of concentration at one layer dated to the exact onset of the younger Dryas raised questions that didn't really sit still. It implied forces beyond ordinary geology had, in a short moment, reshaped Earth's surface. Adding to the growing list of oddities was melt glass, tiny fragments of glass created when rock and sand get melted, found at several locations in that boundary layer. These glasses showed chemistry and textures pointing to formation at temperatures way higher than anything a wildfire or volcanic eruption could manage by itself. At the surface alone, that extreme heat, it sort of insisted in a straight line toward a cosmic origin, either from an airburst-type explosion or from an impact. Maybe the most eye-catching marker was platinum, a pretty rare metal that shows up more often in cosmic materials like asteroids and comets than it does in Earth's crust. Researchers looking at ice cores drilled from Greenland found a steep spike in platinum content, and it sat right at the younger Dryas boundary. Each yearly layer of ice seems to trap particles from the atmosphere, so that spike acts like a timestamp, basically saying that something metal-rich in platinum drifted into Earth's airspace right when the cold snap started. And that platinum anomaly wasn't only Greenland, not really. Later work identified similar spikes in platinum at several archaeological sites across North America, which pushed the idea toward a wide, continent-wide event, or maybe even wider than that, hemispheric dusting. For scientists who favor the impact theory, this platinum signature was like the nearest thing to a smoking gun. It felt as if it confirmed that a cosmic visitor had left physical and chemical fingerprints that lined up in time with the black mat and with the sudden climate shift. This whole emerging picture uncovered hints pointing well beyond local environmental change or the slow grind of climate cycles. It implied a planetary-scale jolt, triggered by something falling from space, a dramatic trigger that could reorganize ecosystems, wipe out megafauna, and unsettle human cultures in one severe instant. Still, even if those tiny chemical and mineral clues make a persuasive narrative, getting the full meaning required deeper analysis, more corroborating evidence, and less guessing, if you know what I mean. The microscopic evidence was only the beginning, as scientists continued to probe the boundary with increasingly precise tools, uncovering even stranger materials that further complicated and enriched the picture. The microscopic evidence explored. The story hidden in that thin black boundary deepens under the microscope, revealing materials that defy easy explanation. Among the most intriguing are the tiny magnetic and carbon-rich spherules extracted from the layer. These are solidified droplets formed at incredibly high temperatures when molten material cools rapidly, usually linked to events like asteroid impacts or massive explosions. Finding concentrated spikes of these spherules at multiple sites globally, but not above or below this layer, hints at a shared, extraordinary origin. Nanodiamonds discovered within the same sediments offer yet another remarkable clue. Not only did researchers find ordinary nanodiamonds, which can form under varied natural conditions, but also a rare hexagonal form known as Lonsdaleite. On Earth, Lonsdaleite is almost exclusively associated with shock pressures generated by cosmic impacts. Such diamonds suggest blistering forces that could not have come from ordinary geological processes like wildfires or slow sedimentation. Adding to the evidence is the discovery of melt glass fragments imprisoned in these boundary layers. Unlike volcanic glass formed by eruptions, this melt glass shows chemical and structural properties indicating it formed under temperatures so extreme that only a cosmic collision or atmospheric explosion could generate them. The presence of this glass implies that parts of Earth's surface were instantaneously melted and fused, a process far beyond anything caused by normal fires. Together, these microscopic markers paint a vivid picture. A high-energy event delivered heat and pressure intense enough to alter Earth's surface on a scale previously unimagined at this time. Yet, each type of evidence alone presents possible alternative explanations, making their convergence critical. It is the simultaneous appearance of spherules, nanodiamonds, and melt glass all concentrated in the same layer, spread across distant sites, that creates a compelling narrative of sudden, cosmic disruption. This suite of indicators defies simple dismissal because they appear in lockstep with the onset of the younger Dryas and the black mat's geographic spread. In a way, it is like finding a fingerprint impressed upon a single thin page in Earth's history, linking otherwise separate phenomena. The microscopic evidence illuminates a sudden upheaval rather than a slow, drawn-out transition. Scientists also found evidence of intense, widespread burning in this layer, with charcoal, soot, and carbon residues peaking across continents at the same time. This suggests massive wildfires erupted globally, or hemisphere-wide, further supporting an explosive trigger that released enormous amounts of particulates into the atmosphere. These fires would have dimmed sunlight and helped plunge the planet into cooling, setting off what has been called an impact winter. Together, these microscopic clues challenge long-standing assumptions about the younger Dryas and raise profound questions about the vulnerability of ecosystems and human societies to cosmic forces. They invite us to reconsider the boundary between Earth's geological record and events beyond our planet. In these tiny spheres, diamonds, and fragments of glass, lies a story of destruction and transformation written in heat, shock, and time. Even as skeptics continue to question aspects of the findings, the growing body of microscopic evidence demands serious consideration, setting the stage for a deeper understanding of that fateful period in Earth's history. The clues suggest that whatever struck the Earth's atmosphere 12,800 years ago, it delivered a sudden, planet-altering blow, one that shaped the climate, extinguished life, and ended an era of human culture in ways we are only beginning to comprehend. The platinum spike and global wildfires. One of the strongest pieces of evidence for a cosmic event at the very beginning of the younger Dryas is that platinum anomaly spotted in Greenland ice cores. Platinum is pretty rare on Earth's surface, yet it's more common in extraterrestrial objects like asteroids or comets. In those ice layers dated to roughly 12,800 years ago, researchers noticed this sharp spike in platinum, and it kinda gives a clean timestamp for something unusual arriving in Earth's atmosphere, right when the planet seemed to slip into sudden cooling, abruptly. That platinum spike wasn't just a Greenland thing. Comparable signals later turned up in sediments across parts of North America, implying the platinum-rich material was spread across a huge area. This, in turn, makes it less easy to frame as a small local accident or as some isolated natural process. Rather, it leans towards something larger, maybe even hemispheric, or possibly global, depending on how you read the spread. And then, alongside the platinum clue, there are other signs pointing in the same direction. Researchers have also identified evidence of widespread burning. From different locations, sediment and ice samples show increases in charcoal, soot, and carbon-rich matter, all tied to intense fires. Some scientists call it one of the harshest biomass burning episodes of the Paleolithic era, as if the fires may have swept across forests and grasslands at nearly the same time. If a comet or an asteroid fragmented up there in the atmosphere, then its airbursts or impacts could have lit up massive wildfires, like really fast and kind of brutal. Those blazes would have thrown a whole lot of smoke, soot, and bits into the sky, and that would block sunlight, leading to planet-wide cooling. So it's tempting to say this kind of sudden explosive happening helped kick off a longer spell of cold, often called an impact winter, which sounds weird but fits. And the wildfire evidence doesn't show up alone. It lines up with other impact markers like spherules, nanodiamonds, and melt glass too. Put together, these clues point to a stretch of extreme environmental strain, where ecosystems may have been wrecked far more quickly than gradual climate change could ever do by itself, at least on that kind of timetable. Taken as one package, the platinum spike, along with the wildfire markers, creates a strong thread between a possible cosmic incident and the abrupt cooling during the younger Dryas. Still, there are questions, like whether the event was all about airbursts or surface impacts, or both at the same time. And yeah, it's not settled. But these ancient chemical and physical traces keep raising this unsettling idea that the sky may have helped reshape Earth's climate, landscapes, and even life itself in basically one catastrophic pivot. The platinum and soot markers represent a crucial piece of the puzzle connecting extraterrestrial impact to terrestrial consequences, but not everyone agrees with this interpretation. Scientific skepticism and conventional theories. Despite growing evidence for a cosmic cause behind the younger Dryas, the impact hypothesis remains controversial. Many mainstream scientists are cautious because the claim is extraordinary, and some evidence remains debated. One major concern is reproducibility. Some researchers have struggled to replicate findings such as microspherules and nanodiamonds, raising questions about contamination, sample differences, or inconsistent testing methods. Critics also argue that certain materials linked to impacts can form through ordinary Earth-based processes. Wildfires, volcanic activity, or even contamination during fieldwork and lab analysis may produce similar particles. This weakens the argument that these markers must have come from a comet or asteroid. Another challenge is the missing crater. If the event was so powerful, skeptics ask why no clear, massive impact scar has been found. Supporters respond that the object may not have struck solid ground directly. A comet fragment could have exploded in the atmosphere, similar to an airburst, or hit the thick North American ice sheet. If the impact happened on ice, the crater could have been erased as the ice melted. This would explain the widespread impact markers without requiring one obvious crater. A more conventional explanation focuses on freshwater flooding. As the North American ice sheet melted, huge glacial lakes such as Lake Agassiz may have suddenly drained cold fresh water into the North Atlantic. This could have disrupted ocean circulation, especially the system that carries warm water northward, triggering rapid cooling without any cosmic event. Many scientists prefer this explanation because it fits known climate mechanisms. They also argue that the extinction of mammoths and other megafauna, along with changes in Clovis culture, may have resulted from several pressures at once. Human hunting, habitat loss, climate instability, and possibly disease could all have contributed. For critics, the impact hypothesis can seem too simple, turning a complex process into one dramatic event. But proponents do not necessarily deny the role of climate or humans. Instead, they argue that a cosmic event may have acted as the final tipping point, pushing already stressed ecosystems and human cultures into sudden collapse. The debate continues because the black mat layer remains difficult to explain. Its timing, widespread appearance, and unusual markers keep drawing scientists back to one haunting question. Was the younger Dryas triggered by Earth's own systems, or by something from the sky? This tension between old explanations and new discoveries keeps the discussion alive, urging science to revisit assumptions and continue probing the thin, dark line where the Ice Age suddenly ended. Converging evidence and changing perspectives. After years of investigation, evidence pointing toward a cosmic event at the very start of the younger Dryas has gotten stronger in the last stretch. Multidisciplinary groups from geology, chemistry, archaeology, and a bunch of related disciplines have kept going back to the black mat boundary, resampling it and reanalyzing with better tools over and over. And weirdly enough, instead of vanishing the major outcomes, the key findings have become more detailed and, honestly, much harder to shrug off. One of the more solid reasons is timing. Sites across North America and even further show comparable signs within the same narrow band, roughly 12,800 years ago. That kind of match implies that whatever formed the black mat and its unusual chemical traces occurred abruptly, and not just in one place, but across huge areas. Things like local wildfires, floods, or a self-contained climate shift have a hard time accounting for that kind of broad synchrony because it would need to be extremely coordinated. Because of this, researchers increasingly look at a bigger cause, maybe a fragmented comet that sort of broke apart in Earth's atmosphere. Not just one giant impact leaving one single crater, but instead multiple bits could have exploded or hit different areas, which means things like airbursts, intense heat, melt glass, spherules, platinum anomalies, and other odd signposts. So, the younger Dryas impact hypothesis has moved from the outskirts to more serious scientific talk. It gives one possible explanation for several major questions all at once: the abrupt cooling, the disappearance of mammoths and other megafauna, and the decline of the Clovis culture. Rather than separate episodes, these shifts could be linked pieces of one planetary disaster. Still, it's not completely resolved. Some scientists prefer ideas involving meltwater floods and more usual natural climate shifts, but the evidence keeps piling up, and it keeps pushing back against older assumptions like Earth's history might be shaped not only from within, but also by things coming in from the sky. The sudden cold, the extinction of giants, and the fall of a human culture may all trace back to one extraordinary event. The evidence buried beneath that thin black line draws a powerful line between past and present, forcing us to rethink Earth's story. If you found this journey into hidden history fascinating, please like and subscribe for more stories that challenge what you thought you knew.